Hello, my name is Alexei Lopez, and today I am going to talk about the ErbB-2 receptor, aka protein. First things first, let's analyze figure A. Figure A, we can find it on the right-hand side of the slide. Let's first say that the objective of this experiment is referring to figure A, which is how RNA interference, also as siRNA and the immunoglobulin could explain unique mechanisms in which the ErbB2 and its transport are present. RNA interference causes a nuclear transport defect and, in mutational terms, impedes higher levels of important beta-1 to be present. Hence, when lower presence of important beta-1 is simultaneously analyzed, the immunoglobulin technique is utilized to detect levels of the ErbB2 protein in both cytoplasmic and nuclear fractions. Next, top panel of figure 8 likely shows the after effect of the reduced levels of the important beta-1 by the RNA interference. And for the fourth point in this slide, we can refer to the top panels here, which is the important beta-1 right here, where my cursor or my mouse is pointing at. And as just to repeat it again, the top panel of figure 8 likely shows the after effect of the reduced levels of important beta-1 by RNA interference, as we can see here in the top panel right here in figure 8, which is the important beta-1. And finally, which is the bottom panel, which is the ErbB2. The bottom panel from figure 8 likely shows the presence of the ErbB2 in the cytoplasmic section, but the lower levels of ErbB2 in nuclear section. So to explain things, to analyze things a little bit deeper, the important beta-1 here has a relation with the ErbB2, and we can see that on the left-hand side of the panel, we see higher levels of ErbB2 present, but then on the right-hand side, we see lower levels of the ErbB2 at the bottom right-hand side of the figure A, or the bottom panel here on the right-hand side of the ErbB2 section. Thus, we can conclude that the important, well, as I said earlier, there was RNA interference that was used to see how ErbB2 levels were affected. And when RNA interference was used, the levels of important beta-1 decreased. And if importing beta-1 decreases, it was shown that the levels of the levels of ErbB2 thus will decrease as well. So they have some some kind of relationship between these two mediums. And thus we can conclude that, so it doesn't make sense when we see at the bottom panel that at the beginning there were higher levels of ErbB2 protein present, and then when we go to the right panel at the bottom, which is labeled ErbB2, we see decreased levels of ErbB2. So thus we can conclude that this is in effect due to the lower levels of the important beta-1 due to the RNA interference. Now let's analyze figure B. Now, and figure B is on the right hand side as well, as we can see here on the slide. And now let's say that the objective from this part of the experiment is likely referring to the effect of the ErbB2 by the absence of the MLS of important beta-1. And also we can say what we can be certainly concluded from figure B is that the important beta-1 that lacks MLS can no longer connect and interact with the ErbB2. To analyze things a little bit further, we can see here that on the top panel here, which is the important beta-1, we see that important beta-1 is present here in the ErbB2 for the wild type, but important beta-1 is missing for the MLS. So we can conclude, so as I said on the first slide, when I talk about the first slide, on figure A, I said that important beta-1 and ErbB2 had some kind of correlation between each other. So we can see here that for the wild type, the ErbB2 is present for the important beta-1, and thus it And thus, we can conclude that it has some kind of correlation with ErbB2. And now, when it comes to the delta NLS, there's no there's no actually nothing here. We can as we can see on the top panel, on the right hand side of the top panel, which is the important beta one. So we can conclude that from this side, or the delta NLS, when it comes to the delta NLS, the importing beta 1 doesn't have any sort of relationship with the ErbB2 because there's nothing on the top panel for the delta NLS. Now my experimental proposition would be that maybe I could have, and maybe that we could have answered the question sooner than later in the interactions and relationships between the ErbB2 and important beta 1 if it could have been analyzed more easier or more thoroughly. I believe researching and analyzing the causations and effects between the important beta 1 has on ErbB2 could make things simpler to understand and more concise. Now let's talk about the ErbB2 in the cytoplasmic, nuclear, and photolysate model. First, let's define some terms which have to do with this part of the experiment. And also, just let me say right quickly that figure C is right here at the bottom. RAN is responsible to transfer proteins across the membranes to the cytoplasm. The responsibility of GTP/GDP is to make GTP become hydrolyzed in order to become RAN GDP. Importing, after becoming bound, it transports cargo proteins into the nucleus and RAN GTP and moves through the MPC. EEF is the medium that allows the exchange of GDP for GTP to form RAN GTP. Now let's talk about the data. For the cytoplasmic fraction, the actual levels of ErbB2 and importing beta 1 remain unchanged. Therefore, there were no changes in the amount of ErbB2 levels, and importing beta 1 didn't affect the ErbB2 levels whatsoever. Let's go back to figure C. As we can see here on the cytoplasmic section, which is on the left-hand side of figure C, we can see that the levels of the top panels and the bottom panels are the same. They have the same amount, so therefore we can conclude that both the ErbB2 and the importing beta 1 have the same amount, and they not only have the same amount, but also there were no changes into their amounts as well. Now for the nuclear fraction, there seem to be similar like amounts of both the ErbB2 and importing beta 1 present. It can be concluded that importing beta 1 can bind to ErbB2 as so known as cargo proteins. As we can see here, there's less amount of the ErbB2 in the importing beta 1, but they're still having similar amounts, and therefore we can conclude they could bind to one another. And now for the immune, now when it comes to exploring the Q69L, it expresses lower amounts of itself, and thus conclusively the importing beta 1 and the ErbB2 levels decrease when the RAN GTP becomes distorted or mutated. Yeah, but as we can see and analyze further, we can see that when it comes to the Q69L, there were lesser amounts, and we can conclude that could be because the RAN GTP became distorted or mutated. And now for the total lysates, the ErbB2 is present in the untreated control wild type and the Q69L, whereas RAN is present in both solidly in the wild type and the Q69L as the ErbB2 is present. For the total lysates, we're just trying to see, when it comes to the total lysates, this is just about checking if the ErbB2 and the RAN are present both in the wild type and the Q69L for both RAN and the ErbB2 or the top and bottom panels. Now the propositional model for part B, I would say that further analyzing and investigating the role of the RAN GTP in relation to the ErbB2 and the importing beta 1 in the nucleus or cytoplasm could be helpful. Also, if researchers use the RAN GTP and NP instead of the RAN Q69L, the ErbB-2 and the importing beta-1 will likely bind inside the nucleus itself and then releasing the ErbB-2 in the nucleus, but unable to bind importing beta-1 because the RAN GPP and P is stuck in the nucleus. Whereas the importing beta-1, it could be found in the cytoplasm. So that would be problematic. A lot of would be really problematic. Therefore, GTP would be fast because GTP would be able to leave the nucleus and go to the cytoplasm in order to bind importing beta-1. And that's the end of my presentation for the second part, for the second part of the exam. And thank you for listening to my presentation. Have a good day.